I will now continue to describe the experimental steps for the electrolysis experiment. It's a fairly straightforward experiment. You need to get a box that contains some of the equipment, so you're going to need the metal, the wires, etc. And then you're going to need a power supply, and the power supply would look like this. And you need a eudiometer, which looks like this, and then you also need a burette stand. All of these equipment should already be in the lab, and you just need to pick them up. So there's usually 3 different metals you can choose from. They all will have tape to them, just as I'm showing here in one of these pictures, where this one says BO2. So your metal is going to have a rectangular shape. You just need to pick one of them, and the first thing you need to do is make sure you sand the metal. So this is a picture of the metal that is before sanding, so you see it's kind of dull. And then this is after sanding, so you can see that there's some kind of scratches there, but that scratching is what exposes the layer of the actual metal underneath this layer of metal oxide. The metal cannot be oxidized unless you remove the metal oxide first, and you cannot oxidize the metal oxide because it's already oxidized. In order to make sure that oxidation takes place, you have to have metal. You cannot have metal oxide. Once you sand the metal, you want to make sure that you rinse it off with water and then followed by acetone. Acetone is an organic solvent that evaporates pretty quickly, and once it's all evaporated, you want to weigh your metal, and that establishes the mass of the metal before electrolysis begins. The next thing is you need to set up your electrolysis apparatus. And it looks something like this. You want your metal to be on one side, that's your anode side. Remember that the electron can't flow unless there is a conductor of some kind. So we're going to use copper wire on the other side just as a conductor of electrons, so the electron can go down into the electrolyte solution, which in this case is a mixture of acetic acid and sodium sulfate. Acetic acid contains the H plus that's going to be reduced to produce the H2 gas. And so this is how it's going to look like. This is my metal, BO2 in this case, and I put it inside a 250 milliliter beaker. And initially, you want to fill this up with about 150 milliliter of that electrolyte solution. So you want to put that metal on one side, clip it with this alligator clip to the side of that beaker so it stays there. And then you notice that on the other side, what I have is this copper wire. The top part is bent so it hangs over the beaker. And then on the bottom side, it's also bent into the eudiometer. So eudiometer looks like this, just basically like a really long tube that has markings on them to help you determine how much gas you've collected. But then you're going to fill this thing up all the way to the brim with the electrolyte solution. Then you're going to turn it over under the water so that the atmospheric pressure will keep the solution inside the eudiometer. The end of that other copper wire will go into the mouth of the eudiometer right here. The other side of the copper wire is going to be clipped onto another alligator clip. Here, the red one is the one that goes to the metal, and the black one is the one that goes to the copper wire. You want to keep the power supply off at this point. You obviously don't want to get electrocuted, so everything should be off before you actually start the experiment. Once you have it set up like this, what you want to do is take the other 2 ends of the wire and then plug it into the power supply. In this particular picture, the power supply is set to on, but what you want to make sure is first it has to be off. You plug in the red into the positive side of the power supply and then the black to the negative side of the power supply. And then the other thing you want to make sure is that this current has to be at the highest position possible. And then once you're ready, then you switch that on. What you should see is bubbling coming out on this side, because electrons are coming off from the metal through the wires. So it goes through this wire, the red one goes out the other side, and then goes into this copper wire, and then it comes out on this side. That electron that comes out on this side is then reacting with the H plus that's floating around in this solution, producing hydrogen gas. So the site of the actual reduction is on this electrode right here. And of course, as the gas bubbles all the way to the top of the eudiometer, that gas is going to pressure the liquid down into the beakers. The top of the eudiometer is going to be more and more empty space, although it's obviously not really empty, but it contains hydrogen gas. So what you want to do is make sure you collect about 45 to 50 milliliter of gas in the first run. Once that happens, turn the power supply off, and then you want to record the actual volume with the correct significant figures of gas that you collect. And what you want to do is repeat that experiment one more time. You're going to fill up your eudiometer with the electrolyte solution, invert it, make sure the copper wire goes underneath it just like this again, and then connect it all to the power supply, and then start it again. And so you get a bubbling again, and then that's your second batch of gas that you collect. In the end, I record that volume again. You're going to add those two numbers together from the first and second trial, and that would be the total volume of gas that you collect. So again, each time it would be between 45 to 50. Once you're done with that, you want to take your metal and then rinse it off again with water, just like you did in the first part. Spray it with acetone, let the acetone evaporate, and then weigh the metal. Since the metal has been oxidized, you're going to get a loss of mass of the metal. After that all happens, you just need to take off the assembly and then return everything back to where you got them from. You're dealing with a voltage here, so you want to make sure that it's off unless you're using it. Acetone is a flammable solvent, so make sure that you're not putting the acetone bottle anywhere near some place that has an open flame, or if there are sparks that might occur. On the safe side, put the acetone a little further away. At the end, once you're done with all the experiments, you're still going to get quite a bit of this electrolyte solution. You need to dispose of all of that in the hazardous waste container because it contains acetic acid. Okay, and that should be the experiment that you need to do. We'll discuss this further when we meet in lab.